So I picked this problem on the warm-up for the warm-up because some of you missed this step on your quiz. So let's look at this. First thing I'm going to do is I'm going to condense. So that means x minus 7 times x plus 1. I still have the log 9 equals 1. Now, to get rid of log when it's on one side, I do the E trick. So then it becomes x squared minus 6x minus 7 equals 9 because 9 to the first power is 9. Everyone with me? X squared minus 6x minus 16 equals 0 because whenever I have an x squared, it needs to equal 0 for me to solve. At this point, you can do the quadratic formula or you can factor. I'm going to go ahead and factor, and I get x minus 8x plus 2. X equals 8. X equals negative 2. Now, something we have not done, you cannot find the log of what type of number? A negative number. Okay, so if I plug in 8 here, 8 minus 7 is 1. 9 to what power is 1? 0. So that one works. Now if I plug in 8 here, 8 plus 1 is 9. 9 to something is 1. What? 1. And 0 plus 1 is 1. So this one works. We did not do this previously. I just had you solve it. Now we're checking solution. Now, when I plug in a negative 2, can I find log 9 of negative 9? No. 9 to some power is not going to give me, because my subscripts are always positive. And you can't go from a positive base to a negative output. Does that make sense? So in this case, the answer would only be x equals 8. Now, so that's a new piece I'm adding. That is not why I did this problem. Up until this point, I accepted both solutions. Now do you see how to test it? We never want the parentheses to be what? Negative when I plug the solutions in. Okay, the reason why I did this is many of you did this yesterday and then just dropped the log 9 and you had 1 over here. You can't just drop the log 9. You have to take it to a base of 9 on both sides, okay? Only a handful missed that, but I wanted to go over it. Oh, yes, yesterday you got, yeah, because yesterday I wasn't checking to see which solutions work, okay? Are we good? All right. Today we're going to look at change of base. So we have log B of A, all right? And this is what happens. The subscript becomes the base. So the old base goes to the base. So I have log B and I have log A. Now, yes, let me explain. This would be, for example, if I had log 8 of 24, let's say. Log 8 of 24. So give me 1 second. There is no power that I can raise 8 to get 24, right? So that's when I would use the change of base, okay? So the trick is old base goes to base, the base of the fraction, and then the other piece goes to the top. You are allowed to then choose any base for your log. I am saying we are going to use the base of 10 because then we can use our calculator. The button on your calculator is base 10. Everyone with me? Okay, so we will use base 10. And now we're going to look at an example. I'm going to move the screen up. Okay, so my example is 2 to the x equals 95. I'm going to show you 2 ways to do this problem, and you decide which works best for you. One way we'll be using this, another way we'll be using it, just another type of just algebra, okay? All right, so using the E trick, sorry, not the E trig, the L trig, I would rewrite this as log 2 95 equals x. Yes? If I use the L trig, I get this equation. We had the E trig, we had the L trig. L trig is just converting from exponential to logarithmic. Okay? Now, I want to be able to solve this. So using the change of base rule, what would I write on my paper? Log 95 over the log of 2. Okay? This base goes to the base of the fraction. So now you can take out your calculator and listen carefully. These need to be in parentheses, so don't forget to close your parenthesis. The calculator does the first parenthesis, you need to close it. So you're going to hit the log button, and then 95 and close parenthesis. They saw you pop up in the announcement. Okay, so what did you get as an answer? Okay, so we're gonna go with 6.57. Round to the nearest hundredth, please. Okay. Okay. That is one method, okay? Now, another way to do it is the following. Okay? So, we have 2x equals 95, okay? So, I'm going to log both sides. When I log both sides, I get x times the log of 2 equals log 95, right? They both work. If there's no way, there's no power that I can raise 2 to easily to get 95. It's going to be a decimal. It would work even if even if this was 2 to the x equals 8, this strategy would work if you couldn't think of what x should be. Okay, but we typically use it if we can't rewrite. Okay, so I want x by itself, so algebraically, what would I do? Divide by log of 2. So essentially, it's the same thing. So x equals log 95 over log 2. It's just showing you the change of base shortcut algebraically. I still get the same answer. Everyone good. So whichever strategy makes more sense. Some people are very structured algebraically and they don't like to use change of base. They are essentially the same. I'm just showing you how they look on paper. Okay, so I have some practice problems that are different from the ones that are on the back of your paper, so you need a separate sheet of paper. Okay, so, all right. Can someone tell me how I start this problem off? Okay, rewrite it. So this is going to be log 6, 81 equals 3x. Right? Let me double check my L trig. L trig. Okay? Good. Now, would you like me to do change of base? Is that the easiest? Okay. So, I'm going to do log 81 divided by log of 6 because the base becomes the base of this one equals 3x. So what am I going to type in my calculator? Log 81 divided by log 6. Get me an answer, please. 2.45 equals 3x. Now, how do I get x by itself? Inverse operation. Divide by 3. Therefore, x equals 2.45 divided by 3 in your calculator. 0.81. 82. You don't want to have a decimal as part of a fraction. Okay. Are we good? Good? All right, moving on. Next example. Okay. In this example, I personally feel that I like to do it algebraically. I like to do it algebraically instead of the change of base one for this one. Okay, so this is what I did. X times the log of 5 equals I logged both sides, which means the power comes down. Everyone good? Okay. Now I'm going to do x equals x plus 3 times log 4 over log 5. It technically is, but I'm trying to keep it easy. Okay, now what would you like me to move? The x plus 3. So now I get x over x plus 3 equals log 4 log 5. You didn't have to do it this way. You could have figured out what the log of 4 is and distribute it. I just felt like this was slightly easier, okay? The log of 4 divided by the log of 5. Log 4 divided by log 5. 0.86, okay? Now I'm just going to cross multiply and solve. So x equals 0.86x plus what? 2.58. Okay, now what do I do? Algebraically, what do I do? Subtract 0.86x from both sides. And that gives me 0.24x equals 2.58. What do I do? Divide. Oh, it's not 0.24. Miss Elena can't subtract today. 0.14. Okay. 1 whole minus point. Okay. Now we divide by 0.14 and we get 18.4. Okay. That is the hardest type there is. That is the hardest type there is. 18.4. I forgot to do the 100th when I did that one. Okay? And so some of you are like, whoa, how did it go up? Because when I divide by a number smaller than 1, your output's going to be bigger. Okay? We good? Yes? All right. Okay, so now this is more practice. 7 to b equals 68. Change of base. What would it be, change of base? Say it again. Can I do change of base yet? No, I got to rewrite it. Log 7, 68 equals b. Now you can do change of base. Go ahead and do it. Okay, so this becomes log 68 divided by log 7, which is? Okay, now. Okay, What is the key piece, though, when you type this in your calculator so you don't get a wrong answer? You gotta make sure you close the parentheses. Okay, somebody set up this one for me. Log 9 of 40 is equal to K. So I do log 40 divided by log 9. Type it in your calculator quickly and you get, wow, somebody's really fast. You guys did it before I assigned it. Wow, you're fast on those buttons. Okay, are we good? All right, two more. All right, these are the harder type. Okay, so I must, okay, what was your question? Okay, so in these ones, before I go from exponential to log, I must have the exponent by itself. So what is my first move in this one? Subtract 7 on both sides. So 18x equals 8. Now it is identical to the last page, yes? You did harder ones in the beginning of the note. Okay, so what do you want me to say? Log 18 of 8 equals x. Okay, so what should I do? Oh, whoa. Log of 8 over log 18. Remember, old base always goes to the basement of the fraction. Okay? And what do you get? 0. And we know we're correct because remember we talked about this before. If my base is bigger than my output, then my answer is going to be less than 1. If I have an output that's less than 1, then my answer is going to be negative. Okay? All right, go ahead and tackle this next one on your own. Okay, what do I do first? Minus 7. So 10 to the x equals 30. Log 10 of 30 equals x. So now what do I do? Log 30 divided by log 10. This line or the fraction? Well, ask it again. I'm asking, going from exponential to log is the question, or going from log to the fraction? Okay, remember the rule is the old base goes in the basement. And what's my answer? Brianna, did you have a question? Oh. Yeah, because that technically is log 10 of 10 is 1. Yeah. That. Did you guys hear that? Log, so this is really log 10 of 10, which becomes 1, so it's really just the answer is log of 30. But if you get caught up in doing the steps, it's fine. So what is x? 1.48. Everyone okay with this concept? Not too bad? Okay. What is the new piece I added to the old concept? Can someone tell me? Okay, if I have two solutions, I should, actually with all solutions I should check, but definitely with two solutions, I want to plug the solution into each of the parentheses, and I never want a negative, okay? Because if I have a positive base, there's no power I can raise it to get a negative number. Just like I can't take the square root of a negative number. It falls in those different rules. Everyone okay? All right, on the back of your note sheet are some practice problems. Get to work.